Okay, good day, students. I believe you're all doing well. I welcome you to the live lecture on MA 280, that is computer appreciation. Under this section, we shall be looking at how to program with the Matlab software. So, this course basically seeks to introduce you students to the Matlab software, and in that, we are going to demonstrate how to come about in finding solutions to some scientific problems. And it is assumed that you've already done something in algebra, statistics, and as well as the basic computer or computing techniques you already know. Now you can contact me through these various medium, and this happens to be your Google Classroom code for now. Now, in this section, we are going to look at introduction to the Matlab software. In there, we are going to see what really Matlab software is. We are going to perform some basic matrix operations, and we are going to explore some graphics. That is under chapter 3, where we get to see some data visualizations. Chapter 4, we shall be dealing with polynomials and how to estimate the functional evaluation of polynomials and all that. And in chapter 5, we are going to see some hands-on practicals with the Matlab software. So this lecture material was compiled from the material of Dr. Adel Yusuf from Istanbul Technical University, and all credit goes to him. So let's look at the first chapter of the software, which is basically the introduction. Now, once we talk about Matlab, Matlab to start with is a high-level language, and from the idea or from the knowledge you guys have obtained so far in the course of your programming and computing courses, we know that once it comes to high-level languages, these are basically languages who have in which their syntax are more related to human let's say human language in the sense or in a simple way. Okay, for instance, if you would like to perform some basic arithmetics, just as add two component of something, you can just use the syntax add component A and B. Okay, and with this high level languages, it gets to give us this flexibility that is so close to our normal human language, and make it so easier for us to comprehend. Okay, so this is far more easier than these low level languages in which you have to write everything in the form of a binary code, in the form of zeros and ones. That makes it so complicated. Okay, and Matlab is not like that. Okay, Matlab is a high level language in which we just get to use syntax which are close to what our normal language that we've been using, and these high level languages are most seen in these latest languages, or should I say modern day languages, such as the R, the Java, the C++. Okay, all these are high level languages. Okay, and they are flexible and they are so easy. Okay, now Matlab also comes in as an interactive development environment. That is to say that Matlab is such that it's more or less like an interface. Okay, if you need something done, just key in whatever you need, and Matlab is obediently going to respond to your query. Okay, and it's just going to do that for you. Okay, now because of this popularity that Matlab has gained, it is being used in so many fields, such as numerical computation. You guys have done numerical analysis, how to estimate the roots using the various methods, Newton-Raphson, bisection, they're all there. Okay, so Matlab could be used to perform such numerical computations. Also, if you should have a data that you like to analyze and see some special or some kind of graphics from this data, you can use Matlab to do so. Now, if you like to develop softwares and algorithms, or you can also use Matlab, okay? And once you are done writing all these lines of codes, you can develop an app with this and also deploy this as well. So Matlab, just listening to the name Math and Lab, okay, it stands for Matrix Laboratory, okay. That is the shortened form of these two words. That is the Matrix Laboratory give us the name Matlab. And this was invented by Clive Muller in the late somewhere 1970s, and it was written in the C language. Okay, it can also work as an interpreter from your previous computing days. We know of interpreter, the compiler. Okay, now the MATLAB is somehow slower than C and Fortran because MATLAB has so many inbuilt functions in there. There are so many things to cater before it gets to what interpret whatever it is being asked to do. MATLAB also contains so many toolboxes. For instance, if you like to perform neural computing, there's a special toolbox for that. If you like to perform classification, there's also a toolbox for that. And there are so many in which you could fall on to do any of your analysis that you want to do. And in terms of graphics, MATLAB is superb if you like to display any forms of plot or whatever. MATLAB can greatly assist you in that. In terms of 2D, 3D, they're all there. MATLAB can just help you with all of this stuff. Okay. Now, basically, this is the interface you guys will see anytime you get to launch your MATLAB. Okay. And let's get to see what really goes on here. Okay. So if you should launch your MATLAB for the first time, basically you are going to come up with these three interfaces. Okay. Now the first one happens to be the current window, and this is where the working directory is being shown. Any file that you can make use of, all of this will be located in the current folder. Okay, and this shows your working directory as well. Now the next phase or the next interface, which happens to be the command window, is more or less like the console. This is where we shall be entering all of our codes. Okay, and for instance, if you like to enter, just like any other software, if you just like to assign, in this case let me just assign one to the variable a, you just enter it in there. Okay, and it just gives you the output just like that. Now you could observe that as soon as I did assign one to a, that is, I created a variable called a, automatically this a appears here. That is the workspace. Okay, and that is the duty of the workspace. This workspace is going to show us all the variables that have been created for this session that we are doing. Okay, so any variable that you assign, any new variable that you create, it will just display here. Okay, so this workspace here is just here to show us the variables that we have in our system, which we can follow later to do analysis. Okay, now coming back to the console, let's try to do one or two basic MATLAB computation here. Now from the first line of code, I did assign 1 to a. Okay, and automatically it just gives me a is equal to 1. Okay, now, however, if you like to suppress this output for now, if you don't like to see the output at a go, you can just use the semicolon. Okay, so suppose that I would like to create a new variable, say called b, which happens to be a sequence from 1 to 5. I can just bring in the semicolon. Okay, and this is just going to what, suppress the output for me for now. Okay, so anytime I would like to call out the output for b, all that I have to do is just what, enter B and just press enter, and you can see this is just going to give me the entries of what, B. Okay, now this suppression is very important, especially if you are running or dealing with so many lines of code. Okay, you cannot just want to see every output at every line, but you can suppress this and produce the final output at the final computation. Okay, so this is also very, very important. Now aside from just entering B, okay, just to bring out the output, We can also use the function that is the this stands for display. So this of b, and that is just going to give us the b. Yeah, so once we do press enter, this is just going to give us our b. Okay, now in similar fashion, what if you like to display a string, or let's say a text? Okay, in this same case you can use the dips. Now because we are about entering a text, we need to introduce in this quotation marks. Okay, so I would like to print hello world. Okay, let me introduce that. Okay, so once you introduce in these quotation marks, then you're good to go. Just close it, and voila, that will print hello world for us. Okay, so you could use this dips function to look out for any display any text of your choice, should it be a program or a long list of word algorithms. Okay, now with this, let's try to do one or two basic things before we move on to the main aspects. Okay, now suppose that for some reason you've lost track of all the variables that you've created in Matlab. You can use the function who, and this is just going to give you the list of variables that you have saved on your workspace. Okay, but what if you like to know more of the properties of these variables? Okay, all that you have to do is just use the function who with an s, referring to what, whose. Okay, and this is just going to give you the dimension of the variable. Okay, the storage capacity, as well as the class of what, the variable that you are dealing with. Okay, now in program, suppose you like to run some program and you like to hear a beep sound at the end of the computation. You can use the function beep, and you hear that kind of beep. Okay, depending on your system that you are using. Also, if you like to know the kind of system or machine or PC that you are using, you can use the function computer, and this computer is just going to give you this output. PC, that is a Windows version, and I'm using a 64-bit version. Okay, architecture. Okay, so that is just going to give you that. Okay, now if you like to know the lowest number Matlab can deal with, okay, you can use the function raw min, and this is just going to give you this number. Okay, meaning that any number below this number, Matlab is just going to treat it as 0. Okay, in that same case, if you like to see the maximum number, you can use the function raw max. Okay, once you do that, this happens to be the maximum number. Any number you specify above this, Matlab will indicate it as infinity. Okay, so suppose that I would like to assign, let's say, a variable c to this number. Because I want it to be greater than, let me use 309. Okay, so as soon as this number exceeds the maximum number in Matlab is just going to denote this to be what, infinity. Okay, now the same thing applies to the real min, but in the real min case, Matlab is going to denote it as simply 0. Okay, so that is also that. Okay, so with this, you could also check for the date of your system, and this is just going to pick up the date from your system right away. Okay, so with this, let's see some other things that we could do from here. Now you could see that when I entered the real marks, okay, the output came as ans, referring to an answer. Okay, now this ans or answer is being created automatically when the operation or whatever I'm trying to do, I don't assign it to any variable. Okay, so for instance, if I would like to perform some computation, that is 2 plus 3, because I'm not assigning this expression to any variable, Matlab is just going to print an answer. Okay, and just give me 5. Okay, and this answer will be what indicated in this what working space. Okay. Now in that also special function just like the pi, you can use the pi function, and that is the explanation for pi. Okay. And also there are so many things that you could also do with this. Okay. So this is just a brief overview of how Matlab works. Okay. So let's get back to our PowerPoint. Okay. So now suppose that you've done so many things and you like to clear your console. Okay. You can just use the CLC function, and this is just going to clear your console for you. Okay. Now in that same case, suppose that you are no more interested in a variable that have been saved in the workspace, you can just use the function clear and just specify the name of the variable. Suppose that I'm no more interested in, let's say, variable, let's say a. Okay, all I have to do is just introduce this a and just press enter. So as soon as I do that, you can see that a has been deleted from the workspace. Okay. However, in case you don't want to see, you want to clear everything in the workspace, you can use clear all. Okay, and this is just going to clear everything in the workspace as easy as A, B, C, D. Okay, so in that same case, if you like to move a little bit up, okay, you can just use this home key. Once you type in home, it's just going to shift everything above and just place you at the right corner of the whole thing. Okay, so suppose that we have so many stuff back here. So we have a is equal to, let's say, 1 as we had earlier, and we type in home. Okay, this is just going to push everything above, and it is just going to land us right here. Okay, as simple as that. Okay, so that is that for the home function. Okay, now let's get to see more. Okay, we've done all this for now. Yeah, now let's see some operators we can make use of once it comes to performing some basic operations in Matlab. We can use all this, that is the plus sign, the minus, the multiplication, the asterisk sign. If you like to perform an element-wise multiplication, you have to use the dots and the multiplication sign. We'll try to move this here. Okay, so that is that. Okay, in that same case, if you like to raise a certain parameter or matrix to a certain power, we can use this symbol. In that same case, if you like to perform an element wise raised to the power, okay, you can use dot. Okay, so just bear in mind that anywhere we have a dot before an operator, we are trying to perform an element wise kind of operation. Okay, in that same case, if you like to perform a backslash, let's say a left division, we are going to make use of this backslash. In that same case, if you like to perform a right division, we are going to make use of this slash operator. If you like to perform an element wise, in both cases, we are just going to place in the period or the full stop there before the operation comes in. Now, if you like to specify a range or a sequence, we can use the colon. That is what we have here. And if you like to perform or transpose a matrix, you will have to use the is it that the single inverted comma. Okay, and that is that. Also, if you like to assign variables to numerics and strings and all that, you can make use of this assignment operator. And in the case of conditional statements, okay, you could make use of this equal to, and this happens to be non-equal to, that is the tilde and the assignment operator. We have the greater, the less than, the greater than or equal to, the less than or equal to, the logical and or not. Okay, we should also have true or false in here. Okay, these are all operators that we could use once it comes to MATLAB. Okay, now suppose that you should have a negative number or negative value and you would like to find its absolute. You can use the function absolute. Okay, that is the ABS. Then you indicate the number or just type in the number or refer to the variable which has been assigned that number. Okay, now if you use ceil, that is going to round off the value in which you place in this bracket to the next what integer. Okay, so suppose that you should have like 2 points, let's say 4 is going to run it up to the next what integer. In that same case, if you should have if you like to reduce it back to the previous integer, you could use the floor. Okay, the floor function, and this is just going to send it that run it down to the previous integer. Now you can use the round to perform the normal rounding of numbers. Okay, and this happens to go to the nearest integer. Okay, now you can find exponent of what numbers. Okay, using the exp function. In that same case, you can estimate the log. Okay, using log, then you specify the number. You can perform log to the base 2. Okay, using log 2, then you specify the number, and our natural, that is our base, the base 10. Okay, and that will be log 10, and you specify the number accordingly. You can also calculate for the modulus. Okay, where we use the function mode. Okay, that is the mod, and you're going to specify the variable and as well as the modulus in which you are working with. Okay, so suppose that you are working at 5 mod 2, so in this case our x is going to be the 5 and our a is going to be the 2. Okay, so that is just going to calculate the modulus for you. Also, we can use the sqrt, that is the square root, to determine square root of any number. Okay, you can also determine the nth root, okay, of any number. Suppose that you like to see the cube root. In this case, you are going to specify the number as x and the roots. In this case, which we are looking for, the cube root, which is 3, we just specify our n to be 3, and this is just going to give us the cube root of any number that we are interested in. We could also perform the factorial of any number using the function factorial, and we specify the number, and that is where you're going to find that. We can find the cosine and the sine of values or numbers. Okay, so once we use the function sine, we specify the value, and that is going to give us the sine of the value we are looking at. We could also use the sine 8, that is the sine 8, that is the hyperbolic sine, then that is going to do that, and we use this function. In that same case, if we like to find the inverse, the sine inverse, we could also use the a sine. Okay, and the inverse of the hyperbolic of sine, we are going to use the a sine. Okay, you do that, that is just going to give you that. Now in the case of cosine, we can use the cos, we just specify the number. Cos, that is the hyperbolic cosine, that is also there, the function. We can use the a cos to determine the cos inverse of any number, and as well as we could use the a cos, that is the inverse of the hyperbolic cosine. Okay, that is also that. In the case of tan, that is also simple, they all follow the same suit. Okay, so you could use tan x, the hyperbolic of tan, the inverse of what tan, as well as the inverse of the hyperbolic what tan, that is the tangent. Okay, so these are all basically hyperbolic functions. Okay, now we could also look at the sine if you like to see the sine in degrees. Okay, now once you introduce the function and you add d, this is just going to give you the answer in terms of what degrees. Okay, the same thing happens to cos and the tangent, and as well as the cotangent, as well as the secant. Okay, once you introduce d at the end of them, this is just going to give you all the values that you want in degrees. Now, with regards to finding the inverses of these functions, we could use the a sine d, that is going to give you everything the inverse in degrees. The same thing happens to a cos d, a tan d, and a cot d, as well as a sec d. Okay, so all this is just going to give you the inverse in degrees. Okay, yeah. Now, by default, Matlab has its number of floating points, or should I say decimal place, to be about 15 precision. Okay, so if you like to work with decimals or something like that, and you like to restrict it, you could use the format function. Okay, now once you specify format short, this implies that any argument from there, or anything that you do, shall be left to 4 decimal places. Okay, so for instance, if I input this function format and I specify short, okay, and I would like to call out the value of a this time. Okay, this is a is 1, and I have, let's say, another variable, let's say b is equal to, let's say, the value of pi, that is 3.142 something something. Let me just add something. Okay, now you could see that immediately I pressed enter, this value that I just entered has been what, rounded, or let's say truncated to only 4 decimal places. Okay, so that is what this format short does. Okay, also you could use format short a, and this format short a is just going to specify everything in the scientific notation, or in the form of what, exponent. Okay, so suppose that I have this, and I now specify format short e, and I press enter. If I should call out for b, let's see what happens here. You can see that now the values here has been transformed into the scientific notation, that is with an exponent. Okay, so this is what the short e will do. In that same case, if you would like to see so many decimal places, we can use the format long. Okay, and this is just going to give you up to about 15 decimal places. Okay, now if you like to see them in scientific notations, you can add format long e, and whatever value that is being given, it is just going to restrict everything to 15 decimal places plus the exponent aspect of it. Okay, now if you like to leave everything to 2 decimal places, you can use the function format bank. Okay, and this is just going to leave everything in 2 decimal places for you. Now with that said, let's get to see how Matlab gets to make use of this its allocation, that is in the form of a matrix. Okay, but before that, let's get to see familiarize ourselves with some basic notations. Now we are all aware what a scalar is. Okay, now once we are talking about a scalar, that is more or less like a constant. Okay, or it's a matrix of 1 by 1 dimension, that is only one row and only one column. Okay, this is referring to like just like a simple, just a constant, this is a single value. Now a vector is more or less like a row, or should I say like a matrix which contains only one row or only one column. Okay, so you can have a row vector or a column vector. Okay, and you should know that this is a one-dimensional array of data, being it column wise or what, row wise. Okay, so there's a scalar, there's a vector. Now let's look at the matrix itself. Now this matrix happens to be a multi-dimensional rectangular array of numbers. Okay, so in this case we should have more than a row, more than more than one row and more than one column as well, and that is just going to give us a matrix. Okay, so for instance, if you would like to create a scalar that is x, okay, so in this case we are assigning a scalar 25 to the variable x. We could just use just as we did for a, we could just assign 25 to a, and once we press enter, this is just going to give us our 25. Okay, we can also assign the number or a scalar 128 to the value y, and that is exactly what we see there. Also, we can think of assigning decimals or floating points to variables just like this. Okay, so in this case we are assigning 12.45 to the variable z, and that is what we have in here. Okay, so as soon as we enter all this and we press enter, Matlab is just going to provide us with the values of x. However, remember from the beginning, if you like to suppress all these values, you would have to make use of the semicolon. Okay, now also we can create a vector. Okay, now once it comes to a vector, meaning that a one-dimensional array, okay, so in this case we are creating a row vector, okay, and that is what we see here. Okay, so we are going to create a vector containing this 1 2 3 4 5 6 entries. Okay, and we are going to assign everything to a. Okay, so in this case we are just going to type in a is equal to, and don't forget your square bracket. Okay, in Matlab, if you like to type in anything, okay, or input in anything, we have to make use of the square bracket, not the other bracket. Okay, so let's take note of this. However, if you like to create a column vector, okay, in this case you have to make use of what, the semicolon. Okay, like after each variable or after each value you have to introduce the semicolon. Okay, so just as we see in here, so in this case we have 12, we have 28, we have 32, all separated by what, a semicolon, and this is just going to arrange the data for you column wise. Also, we can think of creating a matrix. Okay, now remember how we get to separate, that is when we are trying to come up with our column matrix. Okay, we separated each line using the semicolon. Okay, so this happens to be our first row, that is 23, 45 and 67, so that happens to be our first row. So if you like to move on to the next row, we have to use what, the semicolon, then we introduce the next row, semicolon, and the next row, and this is just going to give us what, a 3 by 3, that is 3 rows and 3 what, columns, as we see right here. Okay, in that same case, if you like to do a 2 by 3, you could also specify it, create your first row separated by a colon, and then move on to the next row which we have down here. Okay, now from our previous softwares or programming languages you've done, you know what a variable is. Okay, and we know that variables in these kind of softwares or programming languages are case sensitive. Okay, so that is one thing that we have to bear in mind. Okay, also in the case of assigning variables or creating new variables, they cannot start with a number in the case of Matlab. Okay, they can also not include language characters or language functions, some specific characters that is being allocated specially to Matlab. They can also not include punctuation characters. Okay, and mind you, they should also not include what, spaces. Okay, so in cases where you like to do away or deal with these spaces, you can use the underscore just to separate this kind of stuff. Okay, and that brings us to the end of the first chapter. Okay, so we'll move on to chapter 2 very soon.